I divide this side by 3, I get x plus 4, everything squared. And when I divide this side by 3, I get good. So now I have 4 methods, although we did not discuss the other 2. Factoring. This is already factored. There's nothing I can do here, right? The left-hand side is factored. The right-hand side is a number. I wouldn't even think of factoring, to tell you the truth, because this is a typical situation for which method?
Taking square root.
Excellent. That's all I want you to say. It's typical for taking square roots. Perfect. So then the left-hand side is
X plus 7.
very good. And the right-hand side, and always keep in the back of your mind, what type of equation is this? Well, how many solutions do I have to find?
2.
Because if I omit the plus or minus, I will not get 2 solutions. So be very careful. I also advise you to have a little notebook or maybe just a different color pencil and just circle and say, commit this to memory. Never forget the plus or minus when you take the square root. Never forget the plus or minus because you are not going to get both solutions. You only get one, right? So now the only thing I need to do, please make sure that we are subtracting 4 from both sides, but you do not put the 4 between the plus or minus and the square root. It will make no sense. So I'm not saying you will do it, but I'm just explaining. So 4, which becomes negative 4 on the other side, has to be right after the equal symbol. And these are the 2 solutions. In this case, I will not separate them. It would be a waste of time. In the previous example, I separated them because I was able to simplify them. 3 plus 6, 3 minus 6. But here there is no point because I can't simplify negative 4 plus the square root of 7 or negative 4 minus the square root of 7. So this is good enough. Method number 3, completing the square. Now, completing the square is the third method. And I know you're going to say, really, we really need 4 methods? And the answer is no. But knowing 4 methods is really helping us in solving whenever one of them is better than the other. Now, complete the square is not a method that is useful here. And the question is then, why do we study it? For something else that will come in later in this class. So I would also say that completing the square alone will not solve an equation. So then why? Because something else follows in this class that will use this method. Okay. Now, do you remember on the first day of classes, and let me go back for a second, right there.
Was that last method number 2? Or was just still the number?
The first one was factoring, the second one taking square roots, the third one complete the square, and the last one quadratic formula.
Right, the one we just worked on was number 2 though,
2,
right? Okay.
number 2. Okay, so I'm trying to go back here and go to the first day of classes because I need this. That's the reason why. That's the reason why I needed, and I gave you that form. Do you remember this? This was our agreement that we looked at from the very beginning. And these are 3 special products. You have these 3 special products right here on the factoring form. So you have the difference of squares right here, which is on that form, the first one. And then you have the other 2 right here. So these are so important. We're going to use them over and over. So let me just refresh your memory. A plus b, everything squared is the first term squared plus 2 times the first times the second plus the second term squared. The other one is a minus b, first term minus second term is the first term squared minus 2 times the first times the second times the second term squared. So now coming back to our task, discussing completing the square. So I'm going to choose a problem like, for example, 50 on the same page 167, in which we have x squared plus 4x equals 12. And I'm going to say I would like to use these two terms. Add a third term to both sides of the equation and complete the square. So one more time. First term, second term, third term, and I want to complete the square. In other words, the first term, what is going to be the sign here? Positive or negative? Good. So the first term plus the second term. First term squared is this, plus 2 times the first times the second is this, plus the second term squared is this. Let's do this one more time together. I know it wasn't clear. So, what do you think I squared to get x squared? One more time, what will be the symbol? Good. So now let's figure out, what do you think this second term should be such that the middle term is 2 times x times blah and equals 4x. What should blah be? 2. There is no other way. Would you agree? So the first term plus the second term. First term squared plus 2 times the first times the second plus the second term squared. Can anyone give us the second term squared?
Second term squared?
Yes? Very good. Indeed. It must be 4, right? So x plus 2 squared, the first term squared, plus 2 times the first times the second, plus the second term squared, correct? Am I allowed to add to an equation to both sides, 4 to both sides? Do I change the solutions if I add 4 to both sides?
No.
Of course not. So if I have 1 equals 1, that's the balance. 1 equals 1. And let's say I put 2 to both sides. Am I still in balance? Yeah, because I have 3 equals 3. So I can add 4 to both sides with no problem. Okay, very good. But then, what does the equation become? Before we discuss this. So I have then x squared plus 4x plus 4 equals 12 plus 4. So I did exactly what we agreed. I added 4 to both sides. I cannot just say, I'm going to add 4 to one side and still have a balance. I have to add 4 to both sides. But now, please tell me, what do I replace this by or with? Instead of this, I will have what? Exactly. Exactly, that's how we got the 4. And what about the other side? Exactly. So, what did we do? And you can say, okay, well, what's all this? What did you accomplish? Yes, please.
I'm sorry. Why are we adding 4 to both sides?
To form the perfect square. To form the perfect square, and this is it, right here. If this is x and this is 2, the first term squared is x squared, plus 2 times the first times the second is 4x, and I need a 4. I'm using this formula to determine what I need to add to both sides. This is just the first example. Bear with me and you'll see more examples in a minute. So, is x plus 2 squared x squared plus 4x plus 4?
Yes.
Would you agree with that?
Yes.
Good. So, I'm allowed to add 4 to both sides. I added 4, and I'll explain one more time how we got this 4 in a minute. So, adding 4 to both sides will not change the equation. But then we put all these 3 terms in this one, because we know a binomial squared is a trinomial. Excellent. So x plus 2 squared is the first term squared plus 2 times the first times the second plus the second term squared. You've been hearing this since last Monday, right? Good. So then 12 plus 4 is 16. So far, so good? Okay. I completed the square. I changed this equation into this equation. And now what?
Square both sides.
Take the square root from both sides. So completing the square alone just changes the polynomial a little bit, but it doesn't solve the equation. I have to go back to method 2, which is taking square roots. Exactly. And now we can say, then why? Then why would you go to the extent of completing the square or changing the equation? I won't. This is a method that is used for something else. It works here, but not by itself. Complete the square alone will not solve the problem. So then what would you tell me to write? Very good. X plus 2 indeed equals?
Plus or minus 4.
Awesome! I have to subtract 2, and now I am forced to separate them because I can simplify them. I don't have a square root of 17 or 13 in there. So then one solution is x equals -6, and the other solution is x equals -2. And it's done. And you can go back and check if you would like to. There is no need. Now, allow me to give you the shortcut of the method. Okay? It's the same thing. I just want you to see where it's coming from. So let me choose. Any questions? Any questions? So let me choose another problem. This one will be slightly more difficult, and you'll tell me why it's slightly more difficult. X squared plus 7x minus 8 equals 0. So here is the shortcut of the method. In step number 1, identify the middle coefficient. Can anyone identify the middle coefficient? And remember, they have to be in descending order. So the polynomial has to be in descending order. It is. I have to have 0 on the other side, or I can move -8. If it's easier for you to move -8 first, I'm for it. So can anyone identify the middle coefficient for us?
So x.
Coefficient has nothing to do with x. When we say coefficient, we mean no x. So the middle coefficient is +7.
Oh.
Good. We have to take the number with a sign in front. So it's 7. Number 2, we have to divide 7 by 2. Okay, so it's 7/2.
Why are we dividing by 2? I missed that.
Very good. Here's why. How did we get from 4x, how did we get the 2? Basically dividing 4 by 2. Because of that 2 in the formula. First term squared plus 2 times the first times the second. Right? So that's how we got the 2.
Oh, okay.
Does it click?
Say that one more time.
From the formula, a squared plus 2ab plus b squared. So that's how we got the 2, dividing 4 by 2. Okay? So then 7/2. Then square 7/2. Can anyone square 7/2 for us? How do we square a fraction? Say it again. Awesome. And in 4, add. What am I adding to both sides? What do you think? Exactly. Add 49/4 to both sides. Why is this example a little bit more difficult than the previous one?
There's fractions.
Exactly. 7 is not divisible by 2. 4 was. 4 was divisible by 2, and I was able to find 2 very easily. But since 7 is not divisible by 2, I'm stuck with this 49/4. No problem, though. So I'm adding 49/4 to both sides. Can anyone dictate the new equation? Can anyone tell us what is the new equation, please?
X squared
Yes?
plus 7x
Yes?
plus 49/4.
Awesome. Equals?
8
Yes?
plus 49/4.
Good. Awesome. So one more time. Do we understand how we get to that 49/4?
Yep.
One more time from the beginning. Identify the middle coefficient. I did. 7. Divided by 2. 7/2. Square 7/2. I did. 49/4. Add 49/4 to both sides. Now, what does this equal to? Okay.
Uh,
Give it a shot. Awesome. Sign.
Plus
Very good.
7.
49 over 4. That's my guess.
Not a good guess. Let's do this together. Let's do this together. First term squared plus 2 times the first times the second plus the second term squared.
So 7.
Indeed. Of course. It's what we squared to get 49 over 4. Does it make sense?
Yeah.
Does it make sense? Okay, now the right-hand side is an addition of two fractions. I need the least common denominator from you. Very good. So this is 8 over 1. What will you multiply? Yes?
2 over 4, you multiply 4 in the numerator.
Very good. So then can you please tell me what you get?
32,
Very good. Plus
49.
49. Awesome. So then we have x plus 7/2 squared equals. So this is 81 divided by 4. And after all this, I can't solve. It's not done. What do I do? That's it. That's why you see how taking square roots, how useful it is.
This is insane.
So then x plus 7/2 equals, when I take square root, something crucial must happen. Good. And then plus or minus, what is the square root of 81 over 4?
9 over 2.
Very good. And then I have to move 7/2. And then I have to separate them because I can. So let's do the minus first. -7 minus 9. -7 minus 9 is -16 divided by 2. -8. Let's do the other one. -7 plus 9 divided by 2. Very good. So this equation has two solutions. -8 and +1. Last method. Yes, please.
I'm sorry to point everything up. I just had a question.
Yes.
What happened to the other 49 over 4 on the left side of x squared plus 7x?
Very good question.
Because it just jumped right to
Very good question. When I square a binomial, how many terms do I get?
3 terms.
Good. So the first term squared plus 2 times the first times the second plus the second term squared. So all these three terms are in here.
Oh, okay. All right. Yeah.
A binomial squared is a trinomial.
All right. Yeah. Thank you. Okay. Yeah. All right.
Good. Better? Okay, so let's take a look at the last method, method number 4, quadratic formula. So when we solve a quadratic equation using the quadratic formula, we have to have the equation presented in the standard form. So if I don't have everything on one side in descending order, the equal symbol and 0 on the other side, I cannot use the quadratic formula. The next step is to identify the coefficients, A, B, and C, right? So after you have it in this form, like I asked you about those 3 special products at the beginning of the class, I'm going to ask you to memorize this and make up a tune for it. It's -b plus or minus the square root of b squared minus 4ac divided by 2a. So let's look at one example. Let's say problem 77. I'm just copying the quadratic equation from there on page 167. 2x squared minus 11x plus 3 equals 0. Is this ready for the quadratic formula?
No.
The answer is yes, because everything is on one side in descending order. The equal symbol and 0. It's all set for the quadratic formula. Is it set for taking square roots? No, absolutely not. Very good. Thank you. So then, all I have to do is identify A, with a sign in front, identify B, and identify C. The next step is just plugging them in. Be very careful with the sequence of signs and signs in there. Negative B, that is 11, plus or minus the square root of 11 squared minus 4 times 2 times 3 divided by 2 times 2, which is 4. So let's do this one more time. B is negative 11, so negative B plus or minus the square root of B squared minus 4 times A times C divided by 2A.
So
Yes?
when you stuck 11
Yes?
in the square root,
Yes.
if B is negative 11, you only put 11.
When I square, it doesn't matter.
Okay.
When I square, it's always positive. It's a very good point. Make sure that this quantity is always positive no matter what B is, because it's squared. So don't ever, under the square root, start with minus.
Okay.
Ever. Very good. So then x equals 11 plus or minus the square root of 121 minus 24. 4 times 2 is 8. 8 times 3 is 24, divided by 4. So then x equals 11 plus or minus 121 minus 24 is 97. Very good. Divided by 4.
Can you just slow down?
This quadratic formula is not part of this course. I shouldn't even do it. It's part of the previous 2 courses. Yes, let's go back. Which part is not clear? Where did I?
Don't worry about it.
Oh, no, I have to.
Don't worry about it.
I do. Because if you have a question, I'm sure other students have the same question. Because I would just replace those numbers, or other questions here?
So basically, right in the beginning, right when
Yes.
you said, you just gotta remember this right here. And you
The quadratic
write it
formula?
down. Yep, right in the beginning.
Yes. So once I identify A, B, and C, I just have to plug them in. So B is negative 11, negative B is 11, then plus or minus.
So you just have to memorize that first one right there, negative B
Yes.
plus minus B squared minus
Yes.
4 AC.
Yes. So then negative 11 squared is 11 squared minus 4 times A, which is 2, and times C, which is 3, over 2 times 2, which is 4. And then I squared 11, I got 121. I multiply these, I got 24. I subtract, I got 97. And then the final answer is 11 plus or minus the square root of 97 over 4. Is this good enough? Yes.
So we need to. So do we need to know all the methods, or you need to know the one you're more comfortable with? I'm just like,
I'm only showing one method for each problem.
okay.
Now, if you discover a different method for a particular problem, you can use it. But you have to show all the method.
Yeah, what I'm saying in relation to the 4 methods you showed us, that's what I'm asking.
All 4 methods have to be known.
Okay.
But if you discover something, a deviation from a method on a particular type of problem, I'm fine with it. But yes. And here's a very good question, actually. This is a very good question. So why do I need 4 methods? First of all, I need 4 methods because factoring is not always applicable. Quadratic formula is always applicable. I just said no cell phones, but he's looking and playing with it, and I asked you to put it away. So one more time, factoring is not always applicable. Quadratic formula is always applicable. Always. Now, taking square roots. When do I use taking square roots? Only in certain conditions. When I have x, a quantity with x squared and a number on the other side. Then it's very easy to use taking square roots. And what about completing the square? When will I use it? Never. Unless I am forced to use it for practice, because it's useful for something else. But if you give me any problem, I will never think of completing the square. I will always think of these 3. If factoring works like that, I will factor. If it doesn't, then I will use the quadratic formula. And if any specific situations, I will take the square root. I said have 1 more minute. I know I see you're packing, but I have 1 more minute. I'm looking at it. 6:14. 1 minute. Okay. So in this class, I need every second, let alone 1 minute. Okay. So it's a very good question. Do we understand how these 4 methods work? So we have no choice. We have to know all 4. I wish I could say just study 2 of them and forget about the other 2. I can't say that because they are used in different situations. Any questions for me? So this completes 1.5. So we did finish 1.1, 1.2, 1.5. I have not started 1.6. Our first test will include 5 more sections from chapter 2 and these 2 sections from chapter 1. So we still have a lot to go with chapter 2.
Quiz or like something like a power test or something before.
You have everything in my math lab. I wish I had time to do more here. Yes.
So I'm like basically like trying to say like the way you said it before, that so redo the problem that we just did right now, and then